The question of how the universe will end has fascinated scientists and philosophers for centuries. From the dazzling stars in the night sky to the mysterious dark energy driving the cosmos, everything in the universe has a beginning, and perhaps an inevitable end. As we peer deeper into the vastness of space and uncover the secrets of physics, the question becomes more pressing. How will it all conclude? Will the universe drift into an eternal freeze, be torn apart at its seams, or collapse in on itself to start anew? Scientists have proposed several theories about the ultimate fate of the universe, with three major scenarios standing out: Big Freeze, Big Rip, and Big Crunch. Each of these theories offers a unique vision of the universe's final chapter. Let's explore them in detail. Big Freeze. The silent end. In the Big Freeze scenario, the universe's relentless expansion, driven by the mysterious and still poorly understood force of dark energy, continues unabated for eternity. Picture this. The galaxies we observe today, once vibrant clusters of stars and cosmic activity, would drift ever farther apart, disappearing one by one beyond our observable horizon. The night sky, once a canvas of sparkling lights, would grow lonelier, darker, and eerily still. Stars, those brilliant furnaces of energy and life, would one by one exhaust their nuclear fuel. Without the gravitational cradle of new stars being born, the cosmos would become a graveyard of cold, lifeless remnants. Slowly, the light of creation itself would be snuffed out, leaving an endless, frigid void. So what happens? Stars burn out. Stellar engines eventually run out of nuclear fuel. They collapse into faint remnants like white dwarfs, neutron stars, or black holes, their once vivid brilliance reduced to ghostly flickers. Planets freeze. Without their stars' life-giving warmth, planets would become icy, barren rocks adrift in an indifferent cosmos. Any hope for life would be extinguished as temperatures plunge to near absolute zero. Thermodynamic equilibrium. The universe edges toward a heat death, where energy spreads uniformly, leaving no gradients to power motion, change, or life. But it doesn't stop there. Over an unfathomable timescale, even the most enduring cosmic structures would succumb. Black holes, thought to be eternal, would slowly evaporate via Hawking radiation, releasing their mass energy in the form of faint radiation until they vanish. What remains is the ultimate silence, a cosmos stripped of motion, light, and structure, a barren expanse colder than the depths of imagination. This chilling scenario presents an almost poetic tragedy. The universe doesn't end with a bang or cataclysm, but with a gradual, inevitable fading away, leaving behind an infinite, quiet void. Big Rip. The violent demise. Imagine the universe tearing itself apart, unraveling into chaos at every conceivable scale. The Big Rip scenario foresees an apocalyptic end, driven by the possibility that dark energy, already accelerating the expansion of the cosmos, might grow stronger as time marches on. Unlike the slow decline of the Big Freeze, this theory suggests a catastrophic event where the very fabric of space succumbs to an unstoppable force. What happens? Galaxies torn apart. As dark energy intensifies, the vast stretches of space between galaxies expand at an accelerating rate. Gravitational bonds, which currently keep galactic clusters intact, weaken and eventually fail. Galaxies drift farther apart until they themselves are shredded into isolated stars. Stars and planets disintegrate. The growing power of dark energy does not stop at galaxies. It targets individual systems, ripping apart stars and planets as their internal forces are no longer sufficient to counteract the expanding fabric of space. Stars collapse, explode, or dissipate, while planets fragment into scattered dust and debris. Atomic annihilation. In the final moments, even the smallest building blocks of matter, atoms and subatomic particles, succumb. The bonds that hold protons, neutrons, and electrons together are obliterated, reducing the universe to an incomprehensible sea of energy. This horrifying vision of the future is nothing short of cosmic annihilation. In its last milliseconds, the universe becomes a frenzy of unmaking, every level of structure disintegrating into the void. The Big Rip leaves behind no remnants, no echoes, and no memory of the cosmos that once teemed with galaxies, stars, and life. It's a violent and dramatic conclusion to existence, and perhaps the most terrifying aspect is its inevitability once set into motion. If the strength of dark energy continues to grow, the countdown to destruction will begin, and there will be no escape from the ultimate cosmic rupture. Big Crunch, a cosmic collapse. In profound contrast to the endless expansion envisioned by other theories, the Big Crunch paints a picture of a universe drawn inward by its own gravity, a cosmos retreating into itself. This scenario hinges on a delicate cosmic balance. If the density of matter in the universe surpasses a critical threshold, gravity could halt the expansion and initiate an era of contraction. Over time, the vast expanse of the cosmos would reverse, folding into an ever-shrinking embrace until all matter converges in an unimaginable singularity. What happens? Galaxies converge. As gravity asserts its dominion, galaxies that once drifted apart are pulled back together. The delicate dance of celestial bodies becomes chaotic, with galactic collisions forming colossal, dense clusters. Stars and planets unite in chaos. In the contracting universe, stars and planets lose their stability, crashing into one another in fiery cataclysms. Black holes grow ravenous, consuming everything in their reach, merging into increasingly massive entities. The final collapse. The contraction reaches its crescendo as every particle of matter is compressed into a singular point of infinite density. This singularity, a state where the laws of physics as we know them cease to operate, marks the end of the universe as we understand it. The Big Crunch offers a profoundly poetic vision. The universe as a cyclical entity, its end intertwined with the possibility of renewal. Could the singularity birthed in the collapse ignite a new Big Bang, giving rise to a fresh cosmos? This tantalizing possibility evokes the rhythm of existence, a cosmic heartbeat where destruction and creation are but two sides of the same eternal coin. From a philosophical perspective, the Big Crunch speaks to the nature of cycles, of beginnings embedded within endings, and of the infinite potential within every conclusion. It challenges us to consider the universe not as a static entity, but as a dynamic, evolving narrative, an eternal story where each chapter builds upon the last. This scenario, steeped in mystery and grandeur, is a humbling reminder of the universe's power to create, transform, and ultimately reset. So which scenario is most likely? Current evidence leans heavily towards scenarios shaped by the enigmatic influence of dark energy, either the Big Freeze or the Big Rip. Observations of distant supernovae and the cosmic microwave background suggest that dark energy is the dominant force dictating the universe's expansion. This relentless push outward seems to favor a future where galaxies drift apart endlessly or face a dramatic disintegration. However, dark energy is far from understood. Its very nature, what it is, why it exists, and how it behaves, remains one of the most profound mysteries in physics. If this mysterious force is not a constant but evolves over time, it could fundamentally alter the trajectory of the cosmos. A weakening of dark energy might allow gravity to take over, setting the stage for a Big Crunch. Alternatively, an unexpected amplification could accelerate expansion to catastrophic levels, solidifying the Big Rip as our ultimate destiny. The fate of the universe is, therefore, tied to our understanding of dark energy and the fundamental forces shaping reality. Future advances in cosmology, astrophysics, and perhaps quantum physics may shed light on this profound puzzle, offering humanity not only answers about the universe's end, but also deeper insights into its very essence. Until then, we are left with tantalizing possibilities and an ever-deepening sense of wonder about the cosmos we inhabit. Will the universe fade into an icy stillness, unravel into nothingness, or collapse into a fiery rebirth? The answer, hidden in the fabric of space-time itself, awaits discovery. While these theories may seem distant and abstract, they serve as a profound reminder of the fragile and transient nature of our existence. The fate of the universe, whether it ends in the quiet, inevitable fade of the heat death, the explosive and dramatic Big Rip, or the cyclical process of Big Bounce, is a topic that continues to captivate not only the scientific community, but also sparks deep philosophical reflection. These theories, although rooted in complex mathematics and cosmic observations, also touch upon existential questions that have intrigued humanity for millennia. What is the meaning of life if everything eventually fades away? What legacy do we leave in a universe that is destined to end, regardless of our actions? The uncertainty surrounding the universe's ultimate destiny compels us to reflect on our own place within the vast expanse of time and space. It reminds us that life, as we know it, is fleeting. Yet, in the grand cosmic scheme, it also feels profoundly meaningful. Our understanding of the universe's fate may change over time as new discoveries are made, but the questions it raises will likely persist as long as we continue to seek meaning in the stars. Whether the universe ends with a whisper, a bang, or a catastrophic tear, these speculations fuel our curiosity and deepen our sense of wonder, pushing us to explore the unknown and expand our grasp of reality. For now, the story of the universe is still unfolding, and we are fortunate to be part of this ever-changing narrative. As we continue to explore, observe, and question, we contribute to a story that is, in many ways, bigger than us. And though we may never fully comprehend the universe's end, the journey to understanding its mysteries is an adventure that we can all share. Thanks for watching. Bye-bye.